Here's the proposed solution. For the relays on ends A and B, let's make the current pickup 1.2, which is 960 amps on the primary. Let's have a definite time delay of 0.5 seconds, and the current direction as forward. For the relays on ends C and D, let's make the current pickup as 1.1, which is 880 amps on the primary. Let's have a time delay of 0 with no curve, and the current direction as forward. Let's now close the circuit breaker. Current will now flow from the power source through feeder 1 and feeder 2 onto the load. If the two feeders are the same length, the currents should be shared fairly equally. Let's now apply a fault on the feeder from A to C and see what happens. The currents will increase substantially on both feeders, with additional current backfeeding from end D to C. Let's now see how all the relays react. All four relays saw an increase in current and therefore picked up. A and B will see current in the forward direction. End C will also see current in the forward direction due to the backfeed from feeder 2. End D will see current in the reverse direction. The first relay to trip will be on end C. There's no time delay and the direction is forward, which is correct. This will then remove the backfeed from feeder 2, and the currents on ends B and D will now reduce below the pickup level. Feeder 2 can now carry on feeding the load. The current on end A still remains high, as it's still feeding the fault. After the time delay of 0.5 seconds, end A will now trip, clearing the fault.